All right. We're now going to start chapter 2, section 2. This deals with the algebra of functions. When we say algebra of something, all we're talking about there is the ability to do these basic operations on whatever we're talking about. Add, subtract, multiply, divide. That's the algebra of stuff. In other words, what we're going to do here is we're going to take two functions and add them together, subtract them, multiply them, and divide them. And then talk about how their domains are affected. If we had two functions, f plus g of x, that's the same thing as taking f of x plus g of x. What does that mean? If you saw this, what would that mean to you? What this one tells us is we either add the two functions together first and then put the x in there, or we could take the functions separately and add the answers together. We'll do examples of these in a second. F minus g of x is the same thing as f of x minus g of x. Product means multiply. F times g of x is the same thing as f of x times g of x. Okay, first off, with these three operations, the domain of all of these is the domain of the smallest of the functions. So what does that mean? So if the domain of f of x was negative infinity, positive infinity, domain of g of x was just positive from 0 to infinity, then the domain of the sum, difference, and product would be of the smaller one, be from 0 to infinity. So the domain of functions is always the smaller of the two. And the last one is the quotient. Quotient means division. This one says f of x over g of x. Whenever you deal with fractions, what stipulation does there have to be? Whenever you have division, there's always one set of rule. There's one specific rule that you have to abide by. No, almost. If the bottom number is negative, just move it on top. That's not a problem. But you can never divide by what? Very good. So the stipulation here is the bottom function cannot equal 0. So these are the examples of the library of functions. Add, subtract, multiply, divide. Let's look at examples of these. let's say f of x is equal to x plus 1, and g of x is equal to the square root of x plus 3. Before we do the algebra of those, let's talk about the domains of these. What's the domain of the first one? Remember, when you talk about domains, there's 3 questions you have to ask. Can the numbers be negative? Can the numbers be positive? Can it be 0? So how about this one? Can these answers be negative? Sure can. If I put -5 in here, -5 plus 1 is -4. That's a legitimate number. How about if I put positive 100? 101, that's positive. If I put -1 in here, -1 plus 1 is 0. So with this one, this is a linear equation. And all linear equations are from negative infinity to positive infinity. It's all real numbers. Because remember what the graph of this one looks like. It looks like this. It's a linear equation. Y equals mx plus b. That's your y-intercept. Your slope is 1 over 1. So up 1 over 1. So your domain is from negative infinity to positive infinity. What's the domain of the second function? What does the graph of square root look like? Can you take a square root of a negative number? No, because the square root of -4 is not -2. Because -2 times -2 is positive. Can it be 0? Can you take a square root of a 0? Yeah, 0 times 0 is 0. So it could be 0. Can you take a square root of a positive number? Square root of 4 is 2. So what we're looking at here, we can only deal with positive numbers. And that's what the graph looks like. Which is also why I cannot stress enough that you guys memorize the library of functions tables that we did. Because once you understand what these look like, it'll help us define the domains of these. So since the smallest number inside this can be 0, what's the smallest x can be? If we take what's inside here and set it equal to 0, what's the smallest x can be? -3. Because -3 plus 3 is what? 0. And we take a square root of 0. That's the smallest we can take. So it means our domain is from -3 to positive infinity. And we're going to talk more about this later on in this chapter called transformations. So you have to be able to look at a function and tell me what the graph looks like and what the domain of those functions are. So part A, tell me the sum f of f plus g of x. So what this really tells us is It's the same thing as if we just take both of those functions and add them together. What is f of x? F of x is x plus 1. That's f of x. Then we have the plus sign. Now g of x is the square root of x plus 3. And that's as far as we can go. That's combining the two functions, adding the two functions together. What's the domain of this function, of the sum of these two functions? Nope. Yeah, I said it has to be the smaller of the two. This is everybody. This is just here. So the domain of this function is from -3 to infinity. F plus g of 6. So what this tells us, we can take it one of two ways. We can either combine the two functions together first and then put 6 in there, or we can take them both separately and add the answers at the end. In other words, what this side here says is we can add the two functions together, which will give us what we just did. So here's f plus g, and there's of 6. Then what that means is now anywhere I see an x inside the equation, I put a 6 in its place. Then I work it out. When I work it out, what do I do first? When I work it out, what do I do first? According to the order of operations. We have to do special operations first. When we read left, right, are there any special operations? Square root. We have to do inside there first. We could have done it, but let's just stick with the rules first. So we have 6 plus 1. 6 plus 3 is 9. Again, we're sticking with the order of operations. Repeat the process. Any special operations? Yes, there's a square root. Can we do anything inside there? No, 9's a 9. Can we take the square root of 9? What does that equal? 3. Repeat the process. Order of operations. Left to right. Any special operations? No. Any multiplication division? No. All we have left is addition subtraction, so we go left to right. 6 plus 1 is 7. 7 plus 3 is 10. So that's what it's telling us. That's the first part. Now we can go to this side here. What this side here says, let's take f of x and g of x separately. So f of x is x plus 1. So I put 6 plus 1. I do that. And the g of x is the square root of 6 plus 3. I do both of these functions independent of each other. 6 plus 1 is 7. 6 plus 3 is 9. Square root of 9 is 3, and it's 10. So which side seems the more easy side to do? The right side, yeah. If we take the functions independently and then find the values and add, subtract, multiply those, that's much easier because it's just no worry about order of operations. All right, let's look at another example. F plus G of -4. So what this one says is we can take F of -4 plus G of -4. But we've noticed something here. Before we even get started, what do we notice? No, no more answers for you. The rest of the course. More so than that. You're right, because it has negative numbers, but more so what? No. Let's go back up here. What is the domain of our operation? -3 is infinity. Is -4 in that domain? No. Since -4 is not in that domain, the answer does not exist. And we can see that it doesn't exist just from the G value. Because if we plugged in -4 inside there, then we get a value of -1. And we can't do that just yet. We can't do that. So that's why it's important. Before you get started, look at your domain. Now we know the domain of our functions. Since -4 is not the domain, we can't use it, can't do anything else about it. All right, now let's specifically look at equations that deal with nothing but the domain. Let's say f of x is x squared minus 4, and g of x is x plus 2. Find the domain of all of these: f plus, f minus, f times, and f divided by g. With what we just talked about, we can answer those. What's our first step? What's our first step? With what our last example taught us. Okay, so what kind of graph is the first one? What does that look like? Big U. Very good. How about the second one? What does that look like? Like that. Right. Okay, that's the first thing. But now with those pictures, what do they help us find? The domains. Those are the important parts. So what's the domain of our f of x?
It's negative infinity to zero or 0 to infinity.
We can put 0 in there.
Okay.
0 squared is 0, minus 4 is negative 4. Remember, it goes on to negative infinity to positive infinity.
Okay.
How about the domain of this one?
Negative infinity to infinity.
So because of that, which one's smaller? They're both the same. So that means the domain of f plus g, f minus g, and f times g, all three of those have the same domain. What domain is that? Very good. Yes, it's both the same. The question you can ask is, why is f times g the same that as f plus g? Because what is multiplication but turbo addition? So it's the same process over and over and over. So the only problem that we have is with that one. Even though the domain of both the top and the bottom are negative infinity, positive infinity, that's where the problem occurs. What can we not have at the bottom? So what would make G 0? What is G?
Just a number.
No. Remember, these are all functions. G and F are functions. So what's the function of G?
Infinity.
No. Do you see it defined anywhere? Did we define G anywhere? Let's try again. Did we define G anywhere? That's G. This is G. It's x plus 2. So we cannot have G cannot equal 0. So x plus 2, what would make it equal 0?
Negative 2.
If x equals negative 2. So the only domain problem we have here is our domain goes from negative infinity to negative 2, and then from negative 2 to positive infinity. That's the only problem we have there, because the only place that's going to give us any trouble is when x is equal to negative 2. What x makes g of x equal 0? We cannot use x equals negative 2. Find that. And it doesn't tell us to find the domain, it just says find that function. Find that function. So what is f plus g of x? What does that equal to? F of x plus g of x. We just talked about that a second ago. What is f of x?
Squared minus one.
X squared minus 4. There's the plus sign. What's g of x?
X plus two.
X plus 2. Very good. F of x equals x squared minus 4. G of x equals x plus 2. So now we combine these two. Can we combine x squared and x? No. Not like terms. Apples and oranges. This is x squared means what?
So
X times x. Is that the same as just x? No. So we have an x squared. So that takes care of that one. Then we have a single x by itself. That takes care of that one. Now we have -4 plus 2. Opposite signs, take the sign of the larger number and subtract them. 4 minus 2 is 2. So there is that answer. What's the graph of this function going to look like?
no.
Yeah, because it has a power 2.
Okay, we don't put another X in it?
It doesn't matter how many x's it had.
Okay.
It just says, whenever you have an equation, look for the highest exponent. Remember, that's called a degree. If it's x squared, it looks like this. If it's x cubed, it looks like this. And so on and so forth. That's the next one. Then we have f minus g of x. Put those together. Remember, that's going to be the same as f of x minus g of x. What's f of x? Very good. X squared minus 4. Do we need parentheses around it? No, because there's nothing in front of it. If it was something like 2x squared, then we put in parentheses because we have a coefficient out there, or 2f of x, I should say. Now here's the minus sign. What's g of x? Does that have to be in parentheses? No. The answer is yes. Whenever you have a minus sign, if I just did it this way, remember, g of x is x plus 2. What is x right now? Is it positive or negative? It's negative because of this minus sign changed it. That minus sign is supposed to change everything after that. So whenever you have a minus sign and you plug something in, always put it in parentheses. Because it has to change everybody in there. If it was a plus, it wouldn't matter because nothing changes. So now we simplify. We can't do anything because we have a parentheses. Can we do anything inside the parentheses? Can we combine x plus 2? No. So we get rid of the parentheses. How? By distributivity. Negative x, negative times positive is -2. See how that negative sign changed everybody's sign inside there? So whenever you do substitution, when you plug in the equations, put them in parentheses if it has a minus sign in front of it. Now combine like terms. There's only one x squared. That's that one. There's a negative x. Now we have -4, -2. They're both negative, so we add them. You see how the answer has changed from the earlier one? Because of that negative sign. There's a subtraction. So be very, very careful. Whenever you have a minus sign, that's why it's always safer when you put things in substitution wise, always put them in parentheses. You can't go wrong. If you don't need it, just take it away. But if it has a minus sign, then you have to distribute to get rid of it. What's the domain of this one? What kind of function is this? What's the graph look like? It's a parabola. So what's the domain of a parabola? Very good. So the domain of this one is -infinity, +infinity. And again, it hasn't changed. Make sense? All right, now let's change them up a little bit. Now we're multiplying them. Is the domain going to change? No, because remember, the top three stay the same. Nothing makes it change. So this is the same thing as saying f of x times g of x. Because we're multiplying them, we have to put them in parentheses. You have to put them in parentheses. So f of x was x squared minus 4. G of x was x plus 2. So it's going to be x squared minus 4, x plus 2. Okay. Can we combine them? Yes, we can. They're all it's saying is multiply. Which process do we use to multiply them? Of all the rules we talked about so far, which one will we use to do here? Remember that rule? Distributivity. I never told you what A was. A could be an equation. What distributive says, when you have two things multiplied together, whatever is in front multiplies to everything in the second one. So what that's it. This is my A. This is my x plus y. So I take this equation, multiply it to x. So I have x times x squared minus 4. That's the first part. Then I have the minus 4. Minus 4 multiplies to the, I'm sorry. So this whole thing multiplies to x. So I have x times x squared minus 4. This whole thing multiplies to plus 2. So plus 2 x squared minus 4. Repeat the process. We have another distributivity. X times x squared gives us what? How many x's do we have now? We have 2 here, we have one more, so we have 3. And we have -4 times x. Then the second one, we have +2x squared, +2 times -4. So positive times negative is negative, 2 times 4 is 8. Can we combine anything else? Are there any more x3s? No. Any more just x's? Any more x squared? No. So only thing we can do here is put them in decreasing order by degree. Whenever you have, these are what are called polynomials. That's a polynomial. Poly means what? Many. Like polytheistic means you have many gods, like the Romans and the Greeks used to have. Nomials are numbers or terms, so you have many terms. We have 4 terms in this case. So you always want to put them in decreasing order of power. Okay, that's one way of doing that one. Let's look at this one again. Because some of y'all may remember what you learned in high school. If it only has 2 terms, there's only 2 terms in both of these parentheses. If it has 2 terms, what's it called?
Binomial.
Very good. Binomial, bi means 2, so it's 2 terms. If it has 3 terms, it's called a what?
Trinomial.
Very good. Like ax squared plus bx plus c. That's a trinomial. It has 3 terms. But inside these parentheses, they're both binomials. You remember something in high school called FOIL, which is an acronym, which stands for what?
First, outer, inner, left.
Very good. So it says when we multiply these, the first terms, then the outer terms, then the inner terms, and the last terms. Okay, that's just a fancy way of saying take the first term, multiply it to both of those. So x squared times x is x cubed. Y. X squared times x.
Like one on the other.
Yeah, there's an implied one, because this one says there's 2 x's, x, x. And then we have another x. So now that means that there's 3 x's. So there's an implied one. So what we really do, whenever you have the same bases, these are called bases, you add the exponents. So if I had a to the 5th times a to the 10th, what would that equal?
815.
Those are some of the rules. But we'll go through the rules of exponents as we go through this course. So we have x squared times x gives me x cubed. Then x squared times 2 is 2x squared. That one's finished. -4 times x is negative 4x. Negative 4 times positive 2. Negative times positive is negative. 4 times 2 is 8. Then we combine like terms. You notice we get the same answers. And we'll do plenty more of those. If you didn't catch that, we'll do plenty more of those in this course, so don't worry about it. So what's the domain of this function? What's the graph going to look like? No, it's not a parabola. The snaky thingy. Yes, very good. Because it's a 3, it will look like this. It's called a cubic function. A cubic. This is a cubic, which means we have x cubed. Quadratic means we have x squared. That's when it looks like this. Again, memorize the library of functions table that we went through 3 weeks ago. It will make life a lot easier for you as we go on. Also notice if the exponent, if the degree is even, both ends point the same direction. If it's odd, both ends point opposite directions. So that's going to help us with our graphs as we go on from this course. So since it's a cubic function, it's automatically from negative infinity to positive infinity. All right, let's look at the next one. F over G of X. Remember, F of X is X squared minus 4. G of X is X plus 2. So that's the same thing as F of X over G of X. X squared minus 4 over X plus 2. What's my domain?
-2 to infinity or negative, or negative infinity to -2 or negative 2 to
Very good. Because the only thing we can't have is 0 on the bottom. So X plus 2, set that equal to 0. That makes it X equals negative 2. I cannot have that. So the domain is from negative infinity to negative 2. And then from negative 2 to positive infinity. Also, to give you a precursor of what we're going to do further in this course in chapter 3 and 4, what's the graph of this one going to look like? Who'd you guess? That's what that graph's gonna look like. I know, you're asking, how did you get that? We're gonna talk about not anytime soon, but on top, what kind of equation is that? What's that? Okay, you said it. It is quadratic because it has a 2. Very good. This is quadratic. A quadratic equation means we have two answers, which means since it's quadratic, when it says we have two answers, that means we can break it up into two separate equations, two smaller equations. And on the bottom, we have a binomial, which is x plus 2. We're going to learn what's another way we can write 4? What is 4 made up of? 2 times 2, right? So it's 2 squared. Because these are both squared and there's a minus between there, it's called the difference of two squares. Whenever you look at an equation, if it only has two terms and they're both squared with a minus between them, we can now take this equation and break it down to its smaller pieces. So we have to have two x's, one for each one, and then we have to have a 2 for each one, because there's 2 of those. One of them is going to be positive, one of them is going to be negative. That's the difference of two squares. Now, why do we do that? Because now if we do this, can we cancel anything? Which means our equation is really that. That's our equation. And because we took away what this one makes it undefined, remember that was at x equals -2. If we took this equation and put it in there, -2 minus 2 is what? -4. So at -2 equals -4, we have what's called a hole, because we canceled it out of the equation. I'm giving you guys some foreshadowing of what's coming up in the very near future. So just because you have something like this doesn't mean we're done. Whenever you have any exponent thing, that could probably be taken up and make into smaller equations and cancel with the bottom numbers. So the domain of this equation is still -infinity to -2, and then from -2 to +infinity. How about that one? Very good. So it's x plus 2 times x plus 2. Okay, since you answered the first part, can you walk me through the next part? Not yet, because there's parentheses. We have to multiply them first. Very good. Yes. So take the first x, multiply it to both of those. Yeah. So it's 2x. Very good. That's the first x. That's gone. Now we do the other number. Very good. Very good. Now since the parentheses, rule of thumb, whenever you get rid of parentheses, the next step should always be combine like terms. We got rid of the parentheses. There's no more parentheses. Combine like terms. So what combines there? The two x's. So we have 2x plus 2x, which gives us how many x's? 4. Because the coefficient, the number, this 2 in front of the x, that's called a coefficient. Remember back in elementary school, so if I have 2 apples, if I have 2 apples and I have 2 more apples, how many apples do I have? 4 apples. So that's how we combine. So whenever you're adding and subtracting coefficients, you add or subtract those numbers only. The only time the x ever changes, so x plus x is equal to what? 2x. Whenever you add and subtract, you only change the coefficient. Whenever you multiply, what does x times x equal? That changes the exponent. Whenever you multiply or divide, that changes exponents. What if we had this? I see what I said, but no. Here's the reason why. Because there's a rule for exponents, or for radicals. These are called radicals. So if I had radical x times radical y, since they're the same radical, I could combine the insides. That makes sense? Okay. So let's say if I had radical 3 times radical 3. If I had the same number inside there, I could put what in this place? That's be 3 times 3, which is what? What's the square root of 9? Whenever you take a square root of the same square root, multiply them together, what happens is we can write that. Square root of 3 times square root of 3 is square root of 3 squared. Square root and squared cancel each other out. So what we had here is the square root of x plus 2 times square root of x plus 2 is the square root of x plus 2 squared. The square root and the square cancel, so we're left with x plus 2. Make sense? All right. When we talked about the slope, we had 2 points and we drew a line through them and we found the slope between them. But as we've learned, straight lines aren't the only thing we deal with. What about if we have a curve and we have 2 points? Is that the slope of that curve? The answer is no. This is the slope of this line, true, but because of these 2 points being different parts of the curve, that's not the slope of the curve. Whenever you cross a graph at 2 points, that's called a secant line. A secant line crosses a graph at 2 points. So here we have x1 and here we have x2, which means this is y1 and this is y2. That first point is the point x1, y1, and the other one is x2, y2. This is all from chapter 1. We did that in chapter 1. Whenever we have 2 points, we have to label them x1, x1, y1, x2, y2. And we find the slope. So far, so good? Refreshing memories? We call the difference between these, we call those h. H is the distance between x1 and x2. Remember earlier we forgot, that's how we got the slope formula. So we had y2 minus y1 over x2 minus x1. So y2 minus x2 minus x1 is now h. Okay, so that's pretty good. We know that now. We also learned to use the function notations. So y sub 2 is the same thing as f of x2. And then y sub 1 is the f of x sub 1. It's the y value of the first point. So we have f of x sub 2 minus f of x sub 1 over h. Everybody follow me so far, because this is important. If you don't follow me, we can't go any further. All we're doing, we're just using the same slope formula we did from chapter 1. Now, because it's a curve, if we want to know the slope of a curve, it can only happen at one point. So let's say I want to know the slope. So the slope of that curve happens at one point. That's the slope of that curve. It only touches at one point. That's called a tangent line. A secant line crosses at 2 points. A tangent line touches the curve at only one point. So how do we go from a secant line to a tangent line? Remember, a secant crosses at 2 points and tangent only one. So what we have to do is we have to move this point closer to that one. We have to move it closer and closer and closer and closer and closer. In other words, we have to make h smaller. What's the smallest h can become? Remember, what is h? H is x2 minus x1. The smallest h can become is 0, when there's no distance between x2 and x1. So what we need, we can't have x1 and x2. We need to put this one as a term of x1. So since h is equal to x2 minus x1, what does x2 equal? What does x2 equal? X2 is equal to x1 plus h. So x1 plus h minus f of x1 over h. This is the slope of the tangent line. What is a tangent line? It's the line that touches the graph at only one point. So that's the formula. So now we can find, using this as h goes to 0, what that means is h, the distance between x1 and x2, it gets smaller and smaller and smaller. Eventually it becomes 0. Again, what does that mean? It just tells us the slope of the tangent line. How do we find it now? So now we only have one x value. Now we only have one x value. Notice they're all x1s. We need f of x, and we need f of x plus h. Leave h the way it is. Just leave h as h. Eventually, at the end, it's going to cancel out. This has got a name, actually. It's called the difference quotient. The difference quotient is the formula used to find the slope of the line tangent to a curve at one point. To find the slope of the line tangent to a curve at any one point. It's actually a very powerful formula. It's where calculus begins. What you're doing here is what we did in calculus. We start the whole course with this equation. All right, let's look at an example. y equals 3x plus 2. Use the difference quotient, Dairy Queen. Okay, remember, the difference quotient is f of x plus h minus f of x over h. Do we have f of x? What does f of x mean? Yeah, so this is the same thing. It's f of x is equal to 3x plus 2. So we have f of x, check. Do we have f of x plus h? No. So what we do, we have to find f of x plus h. How do we find it? Anywhere we see an x, we put an x plus h in its place. In this equation, anywhere we see an x, we put an x plus h. That's how you find f of x plus h. Anywhere you see an x, put x plus h in its place, in parentheses, of course. Now we have our formula, f of x plus h minus f of x over h. What is f of x plus h? That's this whole part. 3x plus h plus 2. That's this first part. Now we have the minus sign. That's that minus sign. And f of x is 3x plus 2 over h. What did I forget to do? Very good. Since this is a minus sign here, I had to put this f of x in parentheses. Very good. This is the important part. If this is wrong, your answer is going to be wrong. Everybody understand where I got these numbers from? Any questions? Yeah. So what we do now is get rid of the parentheses. How do we get rid of the first parenthesis? Distribute. So we have 3x plus 3h plus 2. That's his first part. This minus sign has to go to everybody inside the parentheses. So it becomes a minus 3x and a minus 2. Okay, everybody okay there? Here's the rule, the first checks and balance system. Everything after this minus sign, when you get rid of it, everything back there has to be canceled with. In other words, everything here has to disappear on our next step. So what gets rid of 3x? Negative 3x, positive 3x cancels. Negative 2, positive 2. So everything here cancels. That leaves us with 3h over h. The h's cancel. We're left with 3. How do I know that's the right answer? What does the difference quotient find for us? What of the tangent line? What of the tangent line? It's the first part that's important. The slope. The difference quotient finds the slope of the tangent line. The slope is 3. Well, did we know that? Look at the equation. This is the same as mx plus b. What does 3 represent? Slope. That's it. So we did that easy one, so we can now move on to more difficult ones. Example 2. F of x equals 1 over x. Now I'm hungry for Dairy Queen burgers. That's my lunch. All right, so in order to find the difference quotient, remember, what's the formula for difference quotient? F of x plus h minus f of x over h. That's the difference quotient. We have f of x, that's given. Do we have f of x plus h? No, we have to find it. Anywhere we see an x in our equation, we put an x plus h in its place. Here's the x, so I put an x plus h in it. You'll get used to doing that. We'll do another one that has a lot more x's in the equation. But anywhere you see an x, replace it with an x plus h. So now our difference quotient, x plus h minus f of x over h. F of x plus h is 1 over x plus h minus 1 over x. All that over h. Since x plus h is an equation, I put that in parentheses. So what do I have to do first? What would you do first? If you had to do this yourself, what would you do first? Can we do anything on top? Can we subtract them? No. The only way you can add or subtract fractions is if you have what? Common denominators. Are they common denominators? No. This one has an x plus h. Does this one? No. So I have to give this one x plus h over x plus h. This one has an x, this one doesn't, so I have to give them an x over x. How does it? Because I have to have the bottom numbers look the same. Remember, this is one equation. This is x plus h, and this is x. So in order for them, LCD is that it's all multiplying together. That was a great question. The question was, how did I know what to do? Because I need the bottoms to look the same. This one doesn't have an x by itself, so I have to put an x down there. And I can't just put it on the bottom. What is x divided by x? Anything divided by itself is what? 1. So x over x is 1. I'm multiplying by 1. X plus h divided by x plus h is also 1. So I'm just multiplying by 1, not changing it, just changing the way it looks. So I know now, since I have a common denominator, they both have an x plus h. This first one is x times 1 is x minus x plus h. These are the most important parts. You have to understand where I got these numbers from and what I did with them. So once I got a common denominator, I just put them all on the bottom. I just worry about the top now. I just worry about the top now. X times 1 is x minus 1 times x plus h is. There's that h. There's that h. So on the bottom, I still have x plus h. On top, I have an x. That's the x. This negative sign distributes to both of those, so I have a negative x. Negative times positive is a negative h. X minus x, these two cancel. So all I have left, here's this h on the bottom, x plus h. On top, I have a negative h. Can't do anything else on top? No. So now I have to combine the top fraction and the bottom fraction. Is the bottom a fraction? It's over. Yes, it is. Yes. It's called a compound fraction. I have a fraction over a fraction. Whenever you have a fraction over a fraction, take the top fraction and leave it alone. This is the top fraction. Multiply that by the flip of the bottom fraction. Can anything cancel? This h and this h cancels. So what do I have left on top? What kind of one? It's a negative one because h goes into h one time. It's a negative one. And on the bottom, we have x times x plus h. But we're not done. Because remember what I said earlier, we're trying to get, since this is the tangent line, what does h become? Zero. So h becomes zero, so it disappears. So all we have left is -1 over x times x, which is -1 over x squared. That is the equation for your slope of that curve. No matter what x you give me, that's the slope of that point. Notice it says it's negative. This is also a test. What does the graph of 1 over x look like? Think back 2.5, 3 weeks ago when we did library of functions. Can x be 0? No. The graph looks like this. The graph of 1 over x looks like this. And if you think about it, if you look at it, any point on this graph has a negative slope. If I'm looking at this point, that's a negative slope. If I look at this point, it's a negative slope. That point, it's a negative slope. So anywhere, any point we pick, it's a negative slope. All right, let's do one more and we'll call it a semester. I'm not gonna lie to you, these will take practice because of the movable steps that are involved. 2x squared minus x minus 3. Find dq. Remember the difference quotient? The formula is f of x plus h minus f of x over h. Do we have f of x? Right there. Do we have f of x plus h? No. So we have to find it. What is f of x plus h? How do we find it? Go to our f function. Anywhere we see an x, what do we put in its place? Anywhere we see an x, we put what in its place? X plus h. So we have 2 times x plus h squared minus x plus h minus 3. Anywhere you see an x, you have to put an x plus h. So it's 2x plus h squared minus x plus h. Notice I put those parentheses around there. Minus, this is that minus, f of x. Whatever comes after the minus goes in parentheses. Remember, all of these have to disappear after our next step. when we combine like terms. Everybody understand where these numbers came from? That's what I'm following the formula. F of x plus h. This is all of this goes here. There's that minus sign, and here's f of x. Order of operations. What's the first thing I got to do?
Special operations,
Which is what?
the parentheses.
Okay, look at the first one. Can we do anything inside there? What can we do then? They're squared. There is a special operation. It's an exponent. So what does x plus h squared, this term, what does that mean?
There's two of them, x plus h times x plus h.
Very good. X plus h times x plus h. Because they're multiplied together, we have to do FOIL. So we have x times x is x squared plus x times h is xh plus xh plus h times h is h squared. Again, you have to practice that. Combine like terms, we get x squared. We combine these two terms here. Xh plus xh is 2xh plus h squared. So this whole equation here goes in place of x plus h squared in there. So it's 2 times x squared plus 2xh plus h squared minus x plus h minus 3 minus 2x squared minus x minus 3. Yes, of course it's going to get bigger first, but then it all crumbles down really quick afterwards. Because using calculus, we'll see our answer is going to be 4x minus 1 when everything is said and done. So what's my next step? Can we do anything inside the parentheses? No, it's really simplified as far as you go. So we have to get rid of the parentheses. So distribute. So we have 2x squared. 2 times 2 is 4xh plus 2h squared. That's the first one. Now we have a minus sign that goes inside the second one. So it changes all of those signs. It becomes a negative x, negative h, the minus 3. Now this, basically, whenever you have a negative in front of a parenthesis, all it does is change the signs inside there. So that positive 2 is now a negative 2x squared. That negative x is now a positive x. That negative 3 is now a positive 3. That's all a negative does if it's outside. Remember, all of these 3 at the end have to cancel. Negative 2x squared cancels with 2x squared. Positive x cancels with the negative x. Positive 3 with a negative 3. And this is what I have left. I can't stress enough, don't cram. I know a lot of students like to just keep on going left and going to the right of the page. Don't. Do it each step, each on its own line, because these equations can get very long, as you just can see. Don't crowd yourself. Because the moment you start losing track of where you are, what signs are, you've lost the answer. Okay, we simplified it. See how short it is? Now what do we do? Can we do anything else algebraically? Look at the top. What do we notice about the top? They all have an H, so we can take out one H out of everybody. Can we take out two H's? No, because this one only has one, this one only has one. They each have one H in common. And the H on the bottom. So if I take out an H out of the first one, what do I have left? 4x. Plus 2. Took out one H here, so I only have one H left. How about the last one? Very good, very good. Because there's a number in front of it. There's a 1 in front of it. I took out the H. There's a 1 left. Very good. There has to be a number there. Because even though I factor out the H, there's still a 1 there holding its place. The H's now can cancel. 4x plus 2h minus 1. H goes to 0. So we're left with 4x minus 1, and that's the slope. For any x you give me, that's the slope of the curve. For any x, that's the slope of the curve. It's a quadratic equation that has a y-intercept at -3 that looks something like this. Yes.
I think I missed the rule, like, why do we have to do that?
Ooh, can anybody answer that? Why do we set h equal to 0? What does h represent?
The smallest possible number making tangent line.
So what does h represent? You're right, but what is, no. What does h represent? Look at your notes.
The difference between 2 points.
Right. H is the distance between x1 and x2. In order to get 1 point on the curve, the h has to be 0. So I set these points, eventually h goes to 0. Then I have the slope at 1 point only. End of section.